Hello everyone and welcome to this session on 8086 Programmable Interrupt Controller 8259. This session is a part of the Module 3 of the course CS305 Microprocessors and Microcontrollers for the 5th semester BTech Computer Science and Information Technology students under the APJ Abdul Kalam Kerala Technological University. Myself Anu Maria Joykutti, Assistant Professor, Department of Computer Science and Engineering, Rajagiri School of Engineering and Technology. First, let's see why do we need a programmable interrupt controller. As we know, for 8086 there are two interrupt pins that we have, the NMI pin and the INTR pin. But consider an application where there are a number of IO devices connected with the CPU and they decide to transfer data using the interrupt driven data transfer mode. So in these type of applications, we require more number of interrupt pins than that is available in a typical microprocessor. Like in the case of 8086, as I said, there are two pins available. Moreover, in these multiple interrupt systems, the processor will have to take care of the priorities for the interrupts simultaneously occurring at the interrupt request pins. So this becomes a difficulty for the processor. To overcome all these difficulties, we require a programmable interrupt controller which is able to handle a number of interrupts at a time. This controller will take care of a number of simultaneously appearing interrupt requests along with their types, their priorities, etc. So this programmable interrupt controller will relieve the processor from all these tasks. Now this 8259 programmable interrupt controller is one such device or one such controller that helps 8086 to take care of the various interrupts. That is, if there are multiple interrupts coming, then the programmable interrupt controller will take care of it. The 8259 programmable interrupt controller, it functions as an overall manager in an interrupt-driven system environment. What it does is that it accepts the request from the peripheral equipment, whichever is requesting for a service, it will accept the request from that particular peripheral equipment. Then it determines which of these incoming requests there are more than one request coming at the same time. Then it will determine which of these requests has got the highest priority. Then whether the incoming request has got a higher priority value than the level currently being serviced. So if it checks whether the incoming request, that is the request that has come just now, has got a higher priority than the request that is currently being served, then it issues an interrupt to the CPU based on this determination. This picture shows the pin diagram of the 8259 programmable interrupt controller. It has got 28 pins. Each of these peripheral devices usually has a specific program that is associated with it, which is known as the interrupt service routine. The interrupt service routine will have the set of instructions that will cater to the specific functional or operational requirements of the peripheral device. That is, whatever that peripheral device intends to do will be contained within the interrupt service routine. Now, the programmable interrupt controller, after it issues an interrupt to the CPU, it has to somehow pass the information to the CPU so that the CPU can point its program counter to this particular interrupt service routine. This pointer which the PIC passes is usually an address in a vectoring table, and this vectoring table is often referred to as the interrupt vector table. This figure shows the architecture or the internal block diagram of 8259. Before proceeding to each of these functional units in detail, let's see the difference between 8259 and 8259A. The 8259 was designed to operate only with 8-bit processors like the 8085. A modified version of 8259, which is known as 8259A, was later introduced that is compatible with 8-bit as well as 16-bit processors. Now let's see in detail about each of the functional units in this architecture diagram. First is the data bus buffer. The data bus buffer is a tri-state bidirectional 8-bit buffer that is used to interface the 8259A to the system data bus. The control words as well as the status information are transferred through the data bus buffer. Next, we have the read-write control logic. The function of this particular block is to accept output commands from the CPU. It contains the initialization command word register, that is the ICW register, and the operation command word register, the OCW registers. These registers store the various control formats for the device operation. This functional block also allows the status of the 8259A to be transferred onto the data bus. Next, we have the interrupt request register and the in-service register. The interrupts that appear at the IR input lines are handled by two registers in cascade mode. They are the interrupt request register IRR and the in-service register ISR. The interrupt request register is used to store all the interrupt levels which are currently requesting for a service. The IRR stores all the interrupt requests in it in order to serve them one by one on the priority basis. The in-service register. The in-service register stores all the interrupt requests those are currently being served. That is, the ISR keeps a track of the requests being served. Next, we have the priority resolver. This priority resolver unit determines the priorities of the interrupt requests appearing simultaneously. The highest priority is selected and stored into the corresponding bit of the ISR during the INTA pulse. Usually, the IR0 has the highest priority while the IR7 has the lowest priority in fixed priority mode. The priorities, however, may be changed by programming the A259A in rotating priority mode. The interrupt mask register, that is IMR. This register stores the bits required to mask the interrupt inputs. The IMR operates on the IRR at the direction of the priority resolver. Now, masking of a higher priority input will not affect the interrupt request lines that are having a lower quality. Next, we have INT or the interrupt pin. This pin goes high whenever a valid interrupt request is asserted. This is used to interrupt the CPU and is connected to the interrupt input of the CPU. The voltage high level on this line is designed to be fully compatible with that of the 8080A, 8085A and 8086 input levels. Next is the INTA pin or the interrupt acknowledge pin. The INTA pulses will cause the 8259A to release the vectoring information onto the data bus. The format of this data depends on the system mode of 8259. The D7 to D0 pins. These pins form a bidirectional data bus. These pins carry 8-bit data either to the control word or from the status word registers. This also carries interrupt vector information. Next, we have IR0 to IR7, which are the interrupt pins. These pins act as inputs to accept interrupt requests to the CPU. So that means that 8259A at a time can accept 8 interrupt inputs. Next is the write pin. The write pin is an active low pin which enables the write input to the 8259A. This enables it to accept command words from the CPU. Next, we have the read pin. The read pin is also an active low pin which enables read input to 8259A. A low on this read pin enables the 8259A to release status information onto the data bus of the CPU. The chip select pin or the CS pin. This is an active low chip select signal for enabling read and write operations of 8259A. Next, we have the cascade buffer or the comparator block. Now, at a time, there can be more than one 8259As connected to the system. So all these 8259As can work in a cascaded mode. So what this cascade buffer or comparator block does is that this block stores and compares the IDs of all such 8259As used in the system. The three input-output pins CAS0 to CAS2 are outputs when the 8259A is used as a master. That is, in the cascaded mode, the different 8259As that are used can either be a master or it can be a slave. So when a 8259A is used as a master, then the CAS0 to CAS2 pins, that is those input-output pins, will be used as output. These same pins will act as input when the 8259A is in its slave mode. The 8259A in master mode sends the ID of the interrupting slave device on these lines. That is, in the master, these are output lines. So what the 8259A does is that it will send the ID of the interrupting slave device, the ID of an interrupting slave device on these lines. That means the one particular slave is getting selected by the master. The slave thus selected will send its pre-programmed vector address on the data bus during the next INTA phase. That is, in the cascaded mode, it is the master which will decide which among the slave 8259A is getting to send an interrupt vector to the processor. Next, we have the SP bar EN pin. This pin is used as an input to designate whether the 8259A is used as a master or it is used as a slave. When it is used as a master, the SP bar will be 1, and if it is used as a slave, then the EN bar will be having a value of 0. Next is the CAS0 to the CAS2. Like as I said, these are the cascade lines. A single 8259A, as we discussed before, has got 8 vectored inputs from IR0 to IR7. If there are more interrupts that are required, then the 8259A can work in cascaded mode. That is, more than one 8259As can be connected in a cascaded manner. In a cascade mode, the master 8259A along with 8 slaves can provide up to 64 vectored inputs. Like we discussed before, these lines, that is CAS0 to CAS2, act as select lines for addressing the 8259A slaves. Let's see the interrupt sequence in an 8086 8259A system. First, one or more IR lines, that is the IR0 to IR7 lines, which are the interrupt request lines, are raised high. That will set the corresponding bits in the interrupt request register. Next, the 8259A, what it does is that it will resolve the priority of these IR lines, and then based on that it will send an interrupt signal to the CPU. The CPU will acknowledge the interrupt signal with an interrupt acknowledge pulse. Once the 8259A receives the interrupt acknowledge pulse from the CPU, the highest priority ISR bit, that is the request which has got the highest priority, the bit that is corresponding to that will be set in the in-service register, and the corresponding bit in the interrupt request register will be reset. The 8259A will not be driving the data bus during this period. Next, the 8086 will initiate a second INTA pulse. During this period, the 8259A also releases an 8-bit pointer onto the data bus from where it is read by the CPU. This pointer is nothing but the type of the interrupt. Next is then the interrupt cycle ends. At the end of the interrupt cycle, the ISR bit, that is the in-service register bit, is reset at the end of the second INTA pulse if the automatic end of interrupt, that is AEOI mode, is programmed. Otherwise, the corresponding bit in ISR remains set until an appropriate end of interrupt command is issued at the end of the interrupt subroutine. Next, let's see in detail about the cascaded mode of connecting 8259. As we said before, a single 8259 has got 8 interrupt inputs. That means the one 8259 can at a time serve 8 peripheral devices. What if the system has got more number of peripheral devices? More than 8 peripheral devices are there. So in order to cater to this, the 8259 can be, more than one 8259 can be used, and these interrupt controllers can be connected in a cascaded manner. So in the cascaded mode of operation, there will be one 8259 that will act as the master, and the remaining 8259s will be the slaves. So in order to connect one 8259 as the master, the SP bar EN pin of that particular 8259 will be connected to VCC, that is a high value, which is clear from the picture. The remaining 8259s, which are the slaves, will have its SP bar EN pin connected to the ground, which is a low value. So that means they will be acting as slaves. Now, the master 8259 will decide which of the slave 8259s are getting selected, so that the interrupt of that particular slave is passed on to the CPU. How does this work? This works by the 8259 master will send the ID of the slave which has been selected using the CAS0, CAS1 and CAS2 pins. Now there are 8 slaves that can be connected. So that requires, so each of the slaves will have a unique ID. So that means there are 2 raised to 3, 8 values that are needed. So there are 3 lines, CA0, CAS1 and CAS2, which are used for passing this ID. So for the master, the CAS0, CAS1 and CAS2 are output as we discussed before. So this output lines will send the ID of the selected slave. And these lines from the CA0, CAS1, CAS2 lines from the master is connected to all the CAS0, CAS1, CAS2 lines of all the slaves. That is clear from the picture. So for the slaves, these pins act as inputs. So when the master sends out the ID, the pins, the slaves will receive the ID value. And if the slave receives its own ID, then it understands that the master has selected it. So what the slave, so each of the slaves will be working independently like a normal 8259A works. So it can receive 8 interrupts at the same time. It will resolve the priority and then it will select a interrupt which needs to be serviced. So that particular interrupt output, that is the INT output of each of the slaves, is connected to the IR input of the master. So when the master selects a slave, first it will send its ID on the CS0, CS1 and CS2 line. The slave in turn will send its selected interrupt into the IR pins of the master. Then the master will in turn pass on this interrupt request on to the CPU. So as we know that there are 8 interrupt input pins for 8259A. So that means that the master can connect up to 8 slaves, and each of the slaves can cater up to 8 input interrupts. So that means there is a total of 8 into 8, 64 interrupts that can be served in the case of cascaded mode. So that's it about the 8259 programmable interrupt controller. Thank you.